this episode of Everyday Science, we're looking at pressure, what it is, what it does, and how the pressure of the atmosphere that surrounds us affects us. We'll lift people off the ground, crush cans, poof peeps, and I have two young scientists who are going to help me out with all of it. I have Grace and Ellis. Are you folks ready to do some experiments?
Yeah.
Oh yeah. Well, we're going to start over here with this thing, and this is going to help teach us about what pressure actually is and where it comes from. So come on in close.
Okay.
Let's take a look at this one. And Alice, we were looking at this earlier, and you know what these little things are here, right?
Yeah, they're airsoft pellets.
They're airsoft pellets for like BBs. They're really, really light. They're very, very light. Underneath here is a speaker. I'm going to connect this up to a power supply that's going to make the speaker cone vibrate up and down. Then watch what the little BBs do. They bounce around.
They dance.
We're going to imagine those are like air molecules. And I've got orange ones and I've got green ones. I've got a lot more orange than I have green. So that's like the molecules of air. We'll imagine that. And when the molecules dance around, they're going to hit this top plate right here. I have this top plate. And I want you to tell me what the top plate does when they hit it.
It rises.
It rises up. And that is exactly what happens in the air around us. And that's where pressure comes from. All the molecules in the air are actually moving around at very high speeds. When they slam into things, that makes pressure. And so that made a force that raised this thing up, as you saw. What could I do to make the pressure bigger? What could I make to make this thing go up higher or go up faster? What change could I make?
Make the balls bounce higher?
Make the balls bounce higher. Oh yeah. And I can turn up the dial here. And that would be like making the molecules of the air go faster. This is like a simulation. We're sort of showing this on a small scale of how that works. So we can make them move faster. And if we make them move faster,
Whoa.
oh yeah, that's a little
cool.
faster. What other change could I make that would give me more
add
pressure?
more pellets.
Add more pellets. Excellent.
Oh, that's
And if we have a lot more pellets, we'll have a lot more collisions. And if we have a lot more collisions, we get a lot more force. It'll raise higher. All right, here we go. And whoa, yeah. Right up to the top, right up to the top. I want you to remember that because everything that we're looking at today, we're dealing with pressure, and pressure in air works like this. But now we're going to make a device to measure pressure. And one of the things that we'll talk about in a later piece of the show is this idea of something called a barometer. We use a barometer to measure pressure. We're going to make one here. Ellis, I need you to hold this. You, Grace, are going to take some liquid and pour it in that funnel and fill up the bottle. And we have the nice orange water, which you've made for us. So go ahead and fill us up. It's going to start coming up the tube. Oh yeah, that's good. And then what we'll do is I'm going to set this off to the side. And Grace, I'm going to give you a chance to use this in just a second.
Oh yeah.
Oh yeah. And Ellis, you're going to bring this forward so that we can see it. And I want to take a look at the water here.
Oh, it's rising up. I hope it doesn't
It
go out of
does.
the
It does
tube.
go up and down. Look at the height of the water here and the height of the water here. What do you notice?
They're the same.
They're the same. And that's because there's the same pressure on this side as there's on that side. They're both open to the air in the room. And the air in the room has the same pressure everywhere. And so it pushes down with the same pressure on both sides.
It's just like milk cartons where the handle is open.
It's the same thing. Well, we're going to take this bottle. I'm going to pump more molecules inside here. This is a device that's going to take molecules from the room and put them in the bottle. And when I do that, what's going to happen to the pressure inside here?
It was rising higher.
Oh, you saw it go? If I put more molecules inside, it's just like we did with the device over here. What's that do to the pressure? Oh, yeah. Pressure goes up, so I have more molecules, and then you can see as I add more molecules, it makes more pressure.
Past your hand.
And the more pressure makes it go up higher. There it goes. We're gonna make it go like off the screen here. Oh yeah. And if I let the pressure out, you can hear it. You can hear the hiss.
Oh yeah.
Where it came from.
And it's gonna be exactly.
It'll be exactly at the same level again. But we're gonna pump on this. And then the liquid level goes up in the straw. And I can make the pressure go up by adding more molecules to the bottle, which is what I just did. But another thing I could do, over here we made them go faster. And we said that was just like taking the air and making it hotter. Make it hotter. And then go ahead and turn that on high. Right there. And go and blow on the bottle. Look at the level. There it goes. And what we're doing is we're making it warmer, and now the molecules are moving faster, and since they move faster, they're slamming into the water harder, they're making more pressure. And go ahead and, that's probably toasty enough. We're gonna drive it off the end there if we're not careful. If I let the air out here, and it's gonna go back down to where it came from,